A disk of radius a by 4 having a uniformly distributed charge 6c is placed in the xy plane with its center at minus a by 2, 0, 0. A rod of length a carrying a uniformly distributed charge 8c is placed on the x-axis from x is equal to a by 4 to x is equal to 5a by 4. 2 point charges minus 7c and 3c are placed at a by 4, minus a by 4, 0 and minus 3a by 4, 3a by 4, 0 respectively. Consider a cubical surface formed by the six surfaces x is equal to plus or minus a by 2, y is equal to plus or minus a by 2 and z is equal to plus or minus a by 2. The electric flux through this cubical surface is to be calculated. So what is electric flux? Electric flux is the integral of the electric field, that is q by 4 pi epsilon naught r square r cap dot product with the area, which is dA into n cap. And in the case of a closed surface, n cap would be the unit normal pointing outside to the surface. This term can be rewritten as, so we have the original q by 4 pi epsilon naught r square into r square times the solid angle subtended by the area at the point charge, and r square can cancel out and we have integral of q by 4 pi epsilon naught integral d capital omega, which is equal to q omega divided by 4 pi epsilon naught. So this is the expression of flux through any surface which subtends a solid angle omega at a point charge. But in case of a closed surface can only subtend a solid angle of either 0 or 4 pi at a point charge. Why is that? If the point charge is inside, then the solid angle would be 4 pi, since the surface is all around the charge. And if the point charge is outside, then some unit normals would point in the direction of charge and some of them would point away from the charge, and therefore the solid angle would be 0. So summarizing that, we have flux is equal to 0 if the point charge is outside, and it is equal to q by epsilon naught if the point charge q is inside. So now we know that the electric flux through the cubical surface is equal to the total charge that is inside the cube divided by epsilon naught. So what is the total charge inside the cube? We have the disk of uniformly distributed charge 6c, and only half of the disk is inside the cube, since the disk is centered on the surface of the cube. So we have 3c from the disk plus the rod of length a has a charge 8c, but the portion of the rod inside the cube is only a by 4. So it contains only 1/4 of the total charge, which means we have 2c from the rod, and the 2 point charges, which are minus 7c and 3c, the only charge that is inside is minus 7c. Therefore the total charge inside the cube is equal to minus 2c. Therefore total flux through the surface is equal to minus 2c by epsilon naught, and hence option A is the answer.